All right, so yeah, we're going to start talking about so the world and the sphere, and the way we place a place on the world is by using longitude and latitude. So if you have a look at this, so we always assume in this topic that the Earth is a nice perfect sphere, and we say that the radius is approximately 6,400 kilometers. So they will assume that in everything. So even in the exams, they'll use that number, okay? So, and we describe, and it's like we put a grid lines all over the world, and we use, and those grid lines are latitude and longitudes. And we use them to place, a spot on the world. So if you actually look in, like your Snapchat maps, this is actually when they're locating. It gives you the longitude and the latitude. Or if you, you call the emergency services because you're lost out in the bush, they pinpoint your phone and they're going to use a longitude and a latitude bearing. Oh, yeah, I guess you call it bearing. All right, so we're going to first look through that. So the longitudes I have put in red there. So the longitudes are the ones that pass through the North and South Pole. So we're seeing them, they go all the way down along the Earth. So they go from the North Pole down to the bottom. They're the longitudes. And then the latitudes are the ones that go around the world that way, sort of horizontal, and they're often small circles. So if you look at the longitudes, you've got your world sphere, and the longitudes are going all the way around. So you can't see it, but it goes all the way around the world. So that is a great circle. So it will have a radius of the 6,400. But when you look at the latitudes, except for this equator one, because the equator is the middle of the world, so that's that line, and it's a latitude. Except for the equator is a large circle or a great circle, and its radius is 6,400. But the rest of them, because as you see, if you go down around the bottom part of the sphere, you can see those circles would get smaller. So the latitude circles get smaller and can be different sizes. All right, so if it's a full circle of the sphere, we call it a great circle. So the equator is the only latitude that's a great circle, and all the longitudes are great circles. Okay, so we've got that. And as we said, we can get small and we can pinpoint a location. So let's go have a look a bit to this. So as I said, we can get great or small circles. So in the latitude. So up here, you can see that circle smaller than the equator one, which is down there in the middle. All right, so when we talk about latitudes, we say how we talk about how we are in terms of the equator. So right here in the middle here, this great circle is the equator. And when they give a latitude bearing or number, they're telling you where you have moved from the equator. So if you go up to, say we're up at the North Pole, up here, the North Pole, what they're going to say is it's on a latitude of 90 degrees north. So from what has happened, if you draw a line along, say, this equator, and you go up to the circle it's up, you can see you're 90 degrees. So the North Pole has a 90 degrees north, so it's north of the equator. And obviously the South Pole would say it's 90 degrees south. So in the latitudes, you're always going to be, latitudes are always given, and you're going to be either north or south, and that is in terms of the equator. All right. So here they're showing you a few more diagrams down here. So we have in Australia or in Melbourne and wherever you're located, we will have a south latitude because we are south of the equator. All right, so we'll be somewhere down in the south, and we'll see that. So you can see here they've given it a few ones. So if you're 30 degrees, so you're on this small circle, that small circle will get called 30 degrees north because it's a latitude. It's gone up 30 degrees from the equator. All right. So, as I said, the longitudes go a full great circle. And we have a zero, like the equator's like our zero latitude. For longitude, so remember the longitudes are going, they're all going to be a great circle and they're all going through. But we have a center one, and that's called the prime meridian. So that's down zero. And what we say for the latitudes is that you're either swinging to the west or you're swinging to the east of that zero line, the prime meridian. So they decided obviously years ago that's going to be the zero line, and it passes through Greenwich, England, but don't worry, they'll just say that the prime meridian and they'll use it zero. So if you look at it, you can, if you're on a point along your, so say I'm on the prime meridian, you could have, say, and then I'm going to say this is the equator. So I'm just going to make one up. So you could be up here on a point up here and a point down here. So if you're on the same prime, this is the prime meridian. So say if I said those 2 points, if I called that one A, I'm going to make it up and I'm going to say this would be 0 degrees, and because it's not moved east or west, but let's just call it 70 degrees north. So it's up on that latitude of 70 degrees north. And then down here, if I called this point B, it would be, and I said this one could be down the same way, but we might say it's down 70 degrees south. So its bearing, because it's on zero, it'll be 0. All right, so if we swing a little bit to the east, so you can see it's this diagram's a little bit deceiving because they put the east on the other side and the west on the other. So let's just pretend we'll do a different one. So if we have the prime meridian, if you have one where you're out here, what that could be is we could say this one's 0. This one could be 20 degrees east. So you could see you can be out that way or you can be out the other way west. All right, so they're going to give you these locations. So any point on the Earth's surface can be described giving a latitude and a longitude. So here's Melbourne's. Melbourne has a 37.8 degrees south. So if we're talking about our world over here, we're down south, so 37 degrees. We're not too far down from there. And it has a longitude of 144 east. So we've gone out this way to the east. Okay, now the longitudes can go up to 180 east or 180 west, because we're going to get 360 if we do a full lap around the circle. All right, so but we saw the north and south, you only go the latitudes, you only go up 90 is the highest, and you can go up to. All right, so we often quote the North Pole and the South Pole. They have a 0 because they're right at the top of the thing. We put them on the prime meridian at the very center, so they have a 0 longitude, but they have their latitudes, which we looked at before. All right, so sometimes we're going to find the distance between two locations, okay? But in this, you're always going to say, when they find the distance between two locations, you're always going to be, there will always be one measurement the same. So there will always be either the same latitude or longitude. So we don't make it too hard for you. So you're either, you're doing a locations on the same latitude, like from here to here, or like before where I did the longitudes, you might be finding a distance between that way. When then don't measure it up. They don't make one like, say, if I put C out here and you have to find the distance like that. They don't do that. You can, like, obviously it can be done, but we're not doing that in further. We're just doing simple between on the same, either the same longitude or the same latitude. Okay, so the first ones we're going to do is the distance between points on the equator. So just to practice, to make it easy. So if you think about, if it's on the equator, we're on the same latitude. Okay, so it's the same latitude, which would be 0. You haven't gone north or south, okay, so 0. Okay, so finding the distance between a point A that has a longitude of 30 degrees west and a latitude of 0. So we're talking about, so we're going to find 2 points, and then they said point B has a longitude of 90 east and latitude of 0. So you can see here where I said they're always going to give it to you with something's the same. So we're saying the same latitude. Now it says find the distance between these 2 points. All right. So if you remember, the equator is a great circle. So its radius is great circle. So its radius will be that 6,400. So you can see when you try to find the distance, if I just pretend this is the circle, the equator going around the world, and we said that this was our 0 longitude would come through here along on the outside. So here's 0. What they're saying is A is 30 degrees west. So it went out here, A, so there's 30 degrees. And they said point B is 90 degrees east. So point B went out here, 90 degrees. So if you look, we've got a formula here, the distance between 2 points on the equator. You're going to use this. And why do we do that? Because you've actually got a circle. And if you think of the circle, the circumference of a circle, so we're going to find this distance out on the outside of this circle. So remember, circumference of a circle is 2 times pi times r, okay? But we only have a certain part of it, so it's like an arc length. And if you look at it, we actually have 120 degrees in there. So you can see here, the pi, they're saying if we worked out this using our arc length formula, all right, I'd say, which is S, I'm going to say it's 2 times pi times the 6,400. And remember, we times it by how much of the circle we've got, which is 120 over 360. You'll see that it simplifies down to being over 180. So they cross that 2 out and they get 180. So you can see I end up with pi times the radius, which is 6,400, so that's written there, times the angle, which was 120 between the two longitudes. So we found out the distance between those two longitudes, and we divide by 180, okay? And give your answer to the nearest kilometre, because we're talking about massive distances. We're not going to do a decimal place here. So let's just do it on the, okay? So just to simplify, you can just use your formula here. So what we would have said is distance equals pi times 6400 times 120 over 180, and we got what was it? 13,404 kilometers between those 2 points on the world. Okay, it's going to be a big distance if someone's gone west and then another point you're going east. You're on nearly opposite side. You are literally on opposite sides of the world, so it's going to be a big distance. All right, going. So here's a few more from distance from a pole or the equator. So Melbourne has a latitude of 38 degrees south and a longitude of 145 east. So find the distance of Melbourne to the equator. So what you would do is you're going to pretend the distance of Melbourne to the equator. So if you think, let's draw them in here, and I'm just going to do that's the prime meridian, the 0 there, and here's the equator. That's your 0 line, and Melbourne was down here. What was it? 145 east and 38 south. So it's going to be. I'll just draw it in the dotted. It's on this 145 east longitude, and it's on the 38 south latitude. So when they ask you to find the distance, so this is Melbourne, from Melbourne to the equator, what you're doing is you're going to find that's the shortest distance in there. So really you're pretending you're on the same longitude. So in this example, when you go between the equator and Melbourne, it's going to be on the same longitude that we're going to find it. So what I mean by that is we're looking on that distance and we're finding, here is the equator. So it goes out, and then here's Melbourne down here. And so Melbourne, look at the latitude, it's gone 38 degrees. So if you look here, so remember a longitude, same longitude, and a longitude is a great circle. So the radius will equal 4 equals the radius. Okay, so you can see down here where they're finding the distance. They've done pi times the radius times the angle in between them, which is 38 over 180, and that's where they find. Now, in the next one, when they say between Melbourne and the South Pole, we're still pretending we're on, so here, we're on the same longitude, but we're going from Melbourne down to here. So Melbourne's at 38, so here is that, and so Melbourne's at 38 already, so it went 38 that way, and South Pole is 90 all the way down. So this distance in here is 52. They find 90 minus the 38 equals the 52. That's how we're finding the distance between those latitudes there. Okay, and then the last one, finding the North Pole. So Melbourne, you've got to go the 38 plus another 90. So those two added together, that's how they get the 128 is the difference between that here, the 128. All right, so that's how you're going to do if you are finding the distance from different points. So really we're on the same longitudes every time. So we always are using a great circle, and we always have the radius as 6,400. So let's give this, here's an exam question, so let's give it a go. It says the city of Karachi in Pakistan has a latitude of 42 north and a longitude of 67 east. Assume the radius of the earth is 6,400. So I told you they'd say that every time. Now, the shortest distance along the surface of the Earth between Karacha and the North Pole in kilometers. So, just so you can get a visual, what you're going to do is you've got, so I'll just draw the equator in there. But what you're going to do is you're going to pretend, because they want Karacha and the North Pole, so here up here is the North Pole, and Karacha is 52 north. So, and on a longitude. So we're going to pretend they're still on the same longitude. So this would be that longitude line of 67 east, okay? But it's up here on the latitude of north 25 degrees. So you're actually on this big red circle, if we look about it, and we've got you've got the equator there. You've got, what was it? Karacha up here at 25 degrees. And then you've got the North Pole up here at 90 degrees. So we know in here must be, oh my God, 65 degrees. All right. So, and if we would go to find the distance, remember the distance, if you wrote the formula, the distance is pi times the radius times the angle, which was 65 over 180. So you're just looking for that one, and that is written out here. See, 65 over 180 times pi, and there you go. All right. Okay, so to summarize up, now we're going to get ones where they're on the same longitude, but, you know, we might not be finding, you know, up to the North Pole or down to the equator or whatever, but we're just going to find different points on the same longitude. So when we have a same longitude, we know it's a great circle and the radius is 6,400, okay? That's always the way. So we've got, this is the formula we're going to use when we have the distance between points on the same longitude. It's going to be pi times the radius times the difference between the angle. So here, up here, they said, so if we read through the question, it said Beijing, China and Perth, Australia have the coordinates of 140 north and 116 east. And then see how they both have the same longitude. So you know you're going to use this same longitude formula. Now, it said Beijing is 40 degrees north of the equator, so there it went up 40, and Perth is 32 south. So the distance in the, and it says find your distance between those 2 points. So I'll do distance equals pi times the radius, which is 640, times the angle. Now, the angle is going to be 40 plus the 32. It's going to be 72 over 180. Okay? Yeah. Up here, we did another example, the example up there, just to be careful with that one. So up here, A was 40 degrees north, and B was 80 degrees north. So the distance between those two is actually only 40, yeah, up there. So that was that example. So down here, this is what we would do to find the distance between that. So you can pop that in on your calc. Okay, so the 8042 kilometers is the distance between Beijing and Perth. Here's another example. It says the diagrams show the position of 3 cities, A, B, and C. According to the diagram, A is located on a longitude. So here we've got to decide which is the correct answer, and it says A is located on a longitude of 60 north. Well, this is definitely wrong. North is given for latitudes. So we're going to get rid of that. That's not right. And B is located on a longitude of 20 east. This one, well, if let's just think about that one, because it could be going around on the other side. So let's have a look. So A and B are located on the same longitude line. Oh, wait a minute, I've missed C. C is located on a longitude of 40 south. So once again, we get rid of that. Longitude has east or west. And A and C are located on the same longitude line. Yeah, we know that for sure. That's definitely. So what happened? Why B isn't? It's gone all the way. It's actually on the other side of the world, and we can't really be sure for a fact. But the A and C we can see is definitely on the same longitude. All right. Okay. Keep going. So here's another one. The Cape Town has a latitude of 34 south and a longitude of 18 east. So once again, if you're on the same longitude, so you know as soon as you see this, same longitude, so it means we're on a great circle. But you can just simply go to the longitude formula, the one where it says same longitude, and you know you got the radius of 644. So, and it says Cape Town's 34 south, Stockholm is 59 north. Assume the radius is that. The shortest distance along the meridian between, so this is, a longitude's called a meridian, so just in case you get confused, they call longitudes meridian, is kilometers. So we just have to think about it. All right, here's your world. They're going on the same longitude. That's the zero, the equator. One is up at, say, 59 north, and the other one's down at 34 south. So the angles between that is 93. So 59 plus 34 is 93. Okay, so we're going to find the distance. It'll be pi times 6400 times the 93 over 180. So let's see what one we get. So we get 10388, which is good because that was the answer to that one. And see, that's question 7. They're not hard, but they get classed as being difficult. I don't understand that, but anyway, let's go. Now it gets a little bit different. Now we're going to talk about if we're finding points on the same latitudes. So just remember, like when we had our world, and we called the equator was the 0 latitude. But remember, when we went up, these circles became smaller. Okay, so when we're finding distances between them, the circles are smaller, therefore the circles have different radius. So the circles, or the latitude circles, have different radiuses. Yeah, radius. Okay, so we can't use the 6,400. They have different radiuses. So what we got to do is, generally you first have to find the radius of the small circle, and we have a formula for that. So what you do is you do 6,400 times cos and the angle of latitude. So we're going to say we're on the same latitude, and we'll pop that in there. So it'll make a little bit sense. So once you've got the radius, then you can find the distance, and you can see when you use the distance, you have to use this new formula, the new radius that you've found. All right, so let's go, we'll do an example, and hopefully that makes sense. So we're going through this question. So Kalgoorlie, Western Australia has a latitude of 31 south and longitude of 120 east. So, and then it says Tamworth has, so here we know, we see that they've got the same latitudes. So we've got to find the distance between the distance between them. So first, so when we know we've got on the same latitude, we've got to find it's the same latitude. We're going to find, So we've got to find the radius. So the radius is going to be that formula up there. So it's 6400 times cos the angle of latitude, that is the same. So if you look here, it's 31 south. So we're going to do cos 31 and we're going to get our new radius. So if I do that on the calc, 5486 kilometers. So now when we go to, now we can use this distance formula. So when I go to find the distance, it's going to equal pi times that new radius, which was 5486, times the distance, the angle between the two longitudes. So if you look, they're both east. So what's happened here is, so if this was our prime meridian, one's out here at, I don't know, one's gone 122 east and the other one's gone 155 east, 51. So when they're on the same east, you pretty much minus it. So 151 minus 122 will give you the difference in the angle. So let's do that. Okay, so we get 29 degrees difference between them. So that's where we'll times that by 29 and divide by 180. And we're going to end up with the distance between them. So we can do that on the, so we get 2777 kilometers. Okay, so just be careful. What I'm saying, when they're see how these are both east, you would just minus them. If one's east and one's west, you add them to find the difference between them. Okay. All right, so last one, let's go through this exam question. So Khalida manufactures a face cream in Dhaka, Bangladesh. Dhaka is located at 24 east and a longitude of 90 east. Assume the radius of the earth is blah, blah, blah. Write a calculations to show the radius of the small circle of the earth's latitude at 24. So you just have to find the radius. So we wrote that formula out before. We said radius equals, it was, can't even remember, 6400 times cos the angle of latitude, which is 24. So you just do that, and it says to show that it is 5847. So don't be stupid, just write what they said it should be in case you stuff it up. Okay, so we got that, and then it says find the shortest distance between Dhaka and Abu Dhabi, whatever it is. Oh, here they've given you the new place, and so if you look at our first one, whatever it was, Dhaka, it was 24 north and 90 degrees east. So find the shortest distance on the small circle. So when they say the small circle, you know you want to be doing the same, it's the same latitude, okay? So we'll use the same latitude formula. So even though they've got different, we're just going to go as if they're on the same latitude, which they are actually. See, 24 north, sorry, 24 north. So let's do the distance. The distance formula is pi times the new radius, which we already found, or they asked us to, times the distance between the difference in their angles. So we've got 90 east minus 54 east, so we get 36 degrees difference over 180, and we'll get the distance. So I'll just do that. It says to the nearest kilometre, which it will often say that, so 3674 kilometres.